Upgrading electrical service in a duplex presents a unique set of challenges. The first challenge involves limited access. Buried mass and cramped fuse boxes can make it difficult to work in the area. Secondly, space constraints are an issue. Finding a suitable location for new panel boards, especially without demolishing bathrooms, is challenging. Thirdly, there's the need for outdoor disconnect switches. If the panels are moved outside of the bathrooms, disconnect switches will be necessary, further complicating the installation. Fourthly, destructive work is likely. Running new wiring and installing new panels will probably involve some destructive work, such as cutting into walls and ceilings. Many electrical contractors prefer to avoid this type of job due to its complexity and potential for problems. However, if the owner is aware of the challenges and is willing to pay for the work, it may be possible to complete the upgrade safely and effectively. If you decide to pursue the job, consider these steps. Firstly, talk to the owner. Explain the challenges and potential costs involved. Discuss the options for panel placement and the need for disconnect switches. Secondly, explore alternative options. Consider the possibility of moving the service entrance to a more accessible location or installing a sub-panel in each unit. Thirdly, get an accurate quote. Estimate the time and materials required for the upgrade, including any necessary destructive work. Fourthly, communicate clearly. Keep the owner informed throughout the process and address any concerns promptly. If the job is accepted, several considerations are in order. Firstly, safety should always come first. Take precautions to protect the property and occupants during the installation. Secondly, use quality materials. Select durable wires, panel boards, and other components. Thirdly, obtain all necessary permits. Ensure that all necessary permits are obtained before commencing work. Fourthly, be prepared for difficulties. Expect to encounter unforeseen challenges and be ready to adjust the plan accordingly. Finally, document the work. Keep a record of the work performed, including any changes or modifications. The decision of whether to take on this job is up to the individual electrical contractor. With careful planning and communication, it may be possible to complete the upgrade successfully. However, the owner should be prepared for the challenges and potential costs involved. When upgrading an electrical service, particularly in older buildings like duplexes, several key areas demand careful consideration to ensure safety, compliance, and long-term reliability. These include load calculations, service entrance equipment, grounding and bonding, overcurrent protection, wiring methods, and adherence to the National Electrical Code, known as the NEC. Accurate load calculations are crucial for determining the appropriate size of the service upgrade. The NEC provides guidelines for calculating both the general lighting and appliance load, as well as specific loads for appliances such as electric ranges, dryers, and air conditioners. It's important to consider both the existing loads and any potential future loads to prevent overloading the system. Service entrance equipment includes the service conductors, meter socket, and main disconnect. The size of the service conductors must be adequate to carry the calculated load, and they must be protected from physical damage. The meter socket must be properly rated for the service voltage and amperage. The main disconnect must be readily accessible and capable of disconnecting all power to the building. Proper grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to return to the source, tripping the overcurrent protection device and preventing electrical shock. Bonding ensures that all metallic parts of the electrical system are at the same potential, reducing the risk of shock. The NEC specifies the requirements for grounding electrodes, grounding conductors, and bonding jumpers. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the electrical system from overloads and short circuits. The size of the overcurrent protection device must be matched to the ampacity of the conductors it protects. It's important to use the correct type of overcurrent protection device for the application, and to ensure that they are properly installed and maintained. Wiring methods refer to the types of conductors and wiring systems used in the installation. The NEC specifies the allowable wiring methods for different applications based on factors such as voltage, amperage, and environmental conditions. It's important to use the correct wiring method for the application and to install it in accordance with the NEC requirements. Adherence to the NEC is essential for ensuring the safety and compliance of the electrical installation. The NEC is a comprehensive set of standards that covers all aspects of electrical design, installation, and maintenance. It's important to be familiar with the NEC requirements that apply to the specific project and to ensure that all work is performed in accordance with those requirements. In the case of upgrading a 60 amp service to 100 amps in a duplex built in 1951, several specific considerations apply. Firstly, the existing service conductors may not be adequate to carry the increased load. It may be necessary to replace the service conductors with larger ones. Secondly, the existing meter socket may not be rated for the increased amperage. It may be necessary to replace the meter socket with one that is properly rated. Thirdly, the existing main disconnect may not be large enough to accommodate the increased load. It may be necessary to replace the main disconnect with a larger one. Fourthly, the existing grounding and bonding system may not be adequate for the increased load. It may be necessary to upgrade the grounding and bonding system to meet the NEC requirements. Fifthly, the existing panel boards may not be large enough to accommodate the additional circuits required for the increased load. It may be necessary to replace the panel boards with larger ones. The NEC Article 220(82) provides an optional method for calculating the load for existing dwellings. This method may be used to determine the minimum size of the service upgrade required. The NEC Article 230 covers service entrances. This article specifies the requirements for service conductors, service equipment, and service disconnecting means. The NEC Article 250 covers grounding and bonding. This article specifies the requirements for grounding electrodes, grounding conductors, and bonding jumpers. The NEC Article 310 covers conductors. This article specifies the requirements for conductor ampacity, insulation, and installation. The NEC Article 408 covers panel boards. This article specifies the requirements for panel board construction, installation, and overcurrent protection. In addition to the NEC requirements, there may be local codes and regulations that apply to the electrical installation. It's important to check with the local authorities to determine the applicable requirements. Upgrading an electrical service is a complex task that requires careful planning and execution. It's important to hire a qualified electrical contractor to perform the work. A qualified electrical contractor will be familiar with the NEC requirements and local codes and will have the experience and expertise to perform the work safely and effectively. When dealing with older electrical systems, several potential problems can arise. These include deteriorated wiring insulation, undersized conductors, outdated overcurrent protection devices, and inadequate grounding. Deteriorated wiring insulation can pose a serious shock hazard. The insulation on older wires can become brittle and cracked over time, exposing the bare conductors. This can create a path for electricity to flow to ground, resulting in an electrical shock. Undersized conductors can overheat and cause a fire. Older electrical systems may have conductors that are too small to carry the current required by modern appliances and equipment. This can cause the conductors to overheat, which can damage the insulation and potentially start a fire. Outdated overcurrent protection devices may not provide adequate protection. Older circuit breakers and fuses may not trip quickly enough to protect the electrical system from overloads and short circuits. This can result in damage to the electrical system or even a fire. Inadequate grounding can increase the risk of electrical shock. A proper grounding system provides a path for fault current to return to the source, tripping the overcurrent protection device and preventing electrical shock. Older electrical systems may not have an adequate grounding system, which can increase the risk of electrical shock. When inspecting an older electrical system, it's important to look for these potential problems. If any of these problems are found, they should be corrected before upgrading the electrical service. In addition to the technical aspects of the upgrade, it's also important to consider the aesthetic impact of the work. Upgrading an electrical service can involve running new wires and installing new equipment, which can be disruptive to the appearance of the building. It's important to work with the owner to minimize the aesthetic impact of the work. One option is to conceal the new wiring and equipment behind walls or ceilings. This can help to preserve the appearance of the building. Another option is to use decorative wiring and equipment. There are many different styles of wiring and equipment available, so it's possible to find something that complements the existing decor. It's also important to be respectful of the owner's property. Take precautions to protect the property from damage during the installation. This includes using drop cloths to protect floors and furniture, and cleaning up any debris after the work is completed. By taking these precautions, you can help to ensure that the upgrade is completed successfully and with minimal disruption to the owner's property. The electrical service upgrade of a duplex, especially one built in 1951, requires careful planning, adherence to codes, and consideration of the building's unique characteristics. The first step involves a thorough assessment of the existing electrical system. This includes checking the condition of the wiring, the capacity of the existing service panel, and the grounding system. Older wiring can become brittle and the insulation can deteriorate over time, posing a safety hazard. It is crucial to inspect the wiring for any signs of damage or wear and tear. The existing service panel may be inadequate for the increased electrical demand. A 60-amp service is generally insufficient for modern electrical needs, especially with electric ranges and other high-power appliances. The grounding system is essential for safety, providing a path for fault current to return to the source and tripping the circuit breaker. An inadequate grounding system can increase the risk of electrical shock. Next, a load calculation must be performed to determine the appropriate size of the new service. The load calculation takes into account the total electrical demand of the duplex, including lighting, appliances, and heating/cooling systems. The NEC provides guidelines for calculating the load, which ensures that the new service is adequately sized to handle the electrical demand. Based on the load calculation, the appropriate size of the new service panel and service conductors can be determined. A 100-amp service is a common upgrade, but it may be necessary to install a larger service if the electrical demand is high. The service conductors must be sized to carry the full load of the service. The service entrance equipment includes the meter socket and the service disconnect. The meter socket must be compatible with the new service. The service disconnect is a switch or circuit breaker that allows the entire electrical service to be disconnected. The location of the new service panel is an important consideration. The NEC requires that the service panel be readily accessible and located in a dry, well-ventilated area. It is generally not permissible to install a service panel in a bathroom or other damp location. If it is not possible to locate the service panel in a suitable location inside the building, it may be necessary to install an outdoor service panel. In this case, a disconnect switch must be installed outside the building, near the service panel. The wiring methods used for the new service must comply with the NEC. The NEC specifies the types of wiring that are permitted for different applications. It is important to use the correct type of wiring for the installation to ensure safety and compliance. Grounding and bonding are essential for electrical safety. The grounding system must be properly installed to provide a path for fault current to return to the source. Bonding ensures that all metallic parts of the electrical system are at the same potential, reducing the risk of electrical shock. The overcurrent protection devices, such as circuit breakers and fuses, must be properly sized to protect the electrical system from overloads and short circuits. The circuit breakers or fuses must be rated for the ampacity of the conductors they protect. The new electrical service must comply with all applicable codes and regulations. The NEC is the primary code that governs electrical installations. However, local codes and regulations may also apply. It is important to obtain all necessary permits before starting work. Upgrading an electrical service can be a complex and challenging task. It is important to hire a qualified electrical contractor to perform the work. A qualified electrical contractor will be familiar with the NEC and local codes, and will have the experience and expertise to perform the work safely and effectively. In the specific case of the duplex built in 1951, there are several additional considerations. Firstly, the existing wiring may be old and deteriorated. It may be necessary to replace some or all of the existing wiring. Secondly, the existing electrical system may not be up to current code. It may be necessary to make some modifications to bring the system up to code. Thirdly, the existing building structure may present some challenges. It may be necessary to make some modifications to the building structure to accommodate the new electrical service. Upgrading the electrical service of a duplex is a significant undertaking. It is important to carefully plan the project and to hire a qualified electrical contractor to perform the work. By taking these steps, you can ensure that the upgrade is completed safely and effectively.